Hello and welcome to the IBM Attack Demo with me, Felix Marks, and my colleague, Craig Roberts. Today we're going to see a demonstration of QRadar and Resilient working together to identify a real attack perpetrated by a hacker using the Kali platform. But before we start the demo itself, let's look at what we're going to see in the demo. So this is a simplified kill chain. At the beginning we see a break-in, and that break-in is going to be achieved with a phishing attack. Then we see the latch on where the attacker starts to see what high value machines are in the estate that he can successfully attack. And specifically we're going to see a pass the hash attack using stolen credentials to break into a high value machine. We're then going to see that attacker damage files as the basis for ransom, establish DNS tunnels for persistence, and for essentially operating any command and control function that the attacker wishes to use. All the way through this attack, we will see what QRadar would have seen within the environments. We'll see that QRadar can see the initial phish by the user's connection to a known malware host, but also by the malware hash of the malware that was downloaded onto the user's machine. We'll see the Nmap port scan that the attacker uses for reconnaissance. We'll see the pass the hash attack, and we'll see hopefully the identification of the actual module that's used. Finally, we'll see the establishment of a DNS tunnel within the environment. Let's begin the demo. Before we go into any depth though, let's just orient ourselves around the screen. On the bottom left-hand side, we can see Kali. Kali is the penetration testing platform, but also the script kiddies platform of choice for attacking organizations. It's a very powerful and very comprehensive platform that contains all of the most useful hacking tools available. On the right is a Windows 8.1 victim machine. During the demo, the attacker, who will reside on the Kali platform, will be attacking the Windows victim machine. Over the top we can see QRadar, and so as the attacks happen during the demo, we'll be able to see what QRadar can see of those attacks. I'm just going to expand the QRadar window now. So the strength of QRadar is its ability to consume very large numbers of logs from all kinds of different sources, whether it's infrastructure like servers and endpoints and network equipment like switches and routers, but also security devices like firewalls and antivirus, and essentially anything that's in the environment. And in a real world environment, this could actually be tens or even hundreds of millions of events per day. QRadar also collects network activity. So in other words, network flow records that it sees traversing the network. In this demonstration system running on my laptop are all of the VMs that are part of the demo that you're going to see, which includes the QRadar console, the QRadar Network Insights appliance, and an app host. We also have the Kali platform as the attacking platform and the Windows machine. And so all of these machines are really connected together, and QRadar is working exactly as it would do in a customer environment. Everything that you see is real. For example, all of this network activity is real network activity that's going on right now. All of the log information is real log information coming from the demo setup. These access permitted events are specifically coming from the firewall that's running on the victim machine. Along the top here, we have a number of other apps, which we're going to see during the demo. We're going to see the User Behaviour Analytics app, identifying risk from internal users. We're going to see the Watson app, which will show us how we can automate investigations into cyber incidents. We're going to see the DNS Analyzer app. This is going to detect the real DNS tunneling which we're going to set up and use. We can see information about the vulnerability of the infrastructure based on QVM's scanning. But all of this work really is to identify actionable security incidents. So the purpose of consuming log activity, network activity, looking at assets, is to be able to work out what is actionable from all of this information. So from the hundreds of millions of records you may be ingesting daily here, the purpose of QRadar is primarily to say, well, now something actionable has happened. And when that happens, it creates what we call an offense. Let's begin the attack. The first part of the attack is where a user logged into the victim machine is sent a phishing email. I'm going to expand this window now and then log in as victim user with the password week123. As this user, I'm going to open up Outlook and I'm going to see that there is an email, actually from me, with the subject line Japanese cars and a very tempting looking link which I'd like to click on called japanesevehicles.us. Download the catalogue, it's awesome. If I hover over that link, I can see that it's actually an IP address ending in .219 in a directory called japanesevehicles.us with an executable which is called ebjesn.exe. So this is malware, a real malware on a real malware site. When I click on this, as the user has been encouraged to do, I'm going to deliberately save that malware onto my machine. It's true that SmartScreen intercepted it, but malware itself has actually landed on my machine, and this is important for the demo. So at the same time as that happens, what did QRadar see? Well, QRadar very quickly spotted that there was a connection to a host categorized as malware, and it's done that on the basis of the firewall log entry for the firewall that's running on the victim's machine. We will also see later that the QNI appliance has seen that malware traverse the network, created a hash for the malware, and used that in a lookup to Xforce to further identify and confirm that it was malware and that the malware is now in the network. So I'm going to right-click on this .219 address here, and I'm going to go to Xforce and see what Xforce knows about this malware site. So this is our .219 IP address, and in here we can see that currently this is categorized with a confidence of 57% as a malware host by Xforce. And here we can see the timeline of that classification going back some years. We scroll down, we can see the domain names that have been associated historically with this IP address, including japanesevehicles.us. We scroll down, we can see the malware that's associated with this IP address, and finally we can see the malware hash, the MD5 malware hash. So Xforce has correctly identified that this malware host has this malware that we've clicked on. We can now see that an offense has been created, internal connection to host categorized as malware. So this offense will contain almost all of the steps of the attack, and the offense ID will stay the same, but the name of the offense will change during the attack as each of the rules fire. Now that the attacker has a foothold in the organization, it's time to look for high-value machines to break into. I'm going to look for a machine on the network with the word finance in it. I can see that there is one called MedFinance with an IP address ending .25. If I ping MedFinance, I can see that it's alive. So now, for the attacker to be able to understand how an attack might be perpetrated, we'll use Nmap to run a port scan of the machine. I'll expand the window for a moment and we can see that Nmap has already discovered the open ports on the machine. It's discovered that, for example, the Samba port is open. It's discovered that there is a service listing on port 5432, which I happen to know is Postgres, and there are a few other ports too. Nmap's power is that having initially discovered the open ports, it's going to drill down and discover what processes or services are listening behind those ports, but it's also going to make a determination about the platform, what the operating system is, for example, and the build number. So as this scan happens, we're going to see what QRadar might see. We go to the Network Activity tab, and we specifically look at the view of port scan. We can see that a port scan is in process. We can tell that because we can see one IP address, this is the Cali IP address of .11, is attacking another IP address, .25. These ports change a lot, and QRadar, seeing this network traffic, is mapping the application names to these ports where they are known. So QRadar is seeing the port scan happen. When QRadar sees enough ports hit over a period of time, in this case about a minute, a rule will fire to cause or to create an offense, and this offense will identify the port scan. Now we can see red dots appearing on the left. These red dots indicate that these network flow records are part of an offense. So if we go back to our Offenses tab, we should be able to see a new offense identifying that port scan. So we now have a new offense with an ID of 569 identifying a potential local port scan. If I double click onto this offense, I can see lots of useful information about the source and the IP. I can see the number of associated events and network flows. I can also see which rules have fired to create this offense. I can see that only one rule is fired, and it's this one, potential local port scan detected. If I open the rule, in the rule wizard, I can see that there are a number of criteria deciding whether or not the rule should fire. These criteria are here, and we can see that the context has to be local to local, and that the source IP has to hit more than 5 times, more than 30 destination ports within a period of time, which is here set to be 1 minute. I don't necessarily want to be notified every time a port scan happens on machines that I don't care about, but on the machine that I really do care about, in this case, where an asset has a defined weight of greater than 7, then I want the rule to fire. You can see here that it's a very simple matter to change any of these values by clicking on them. We'll come back to the offenses in more detail later on. We can now see, now that Nmap has finished running, what Nmap has determined. If we scroll up, we can see that for those open ports that we saw initially, and immediately that Nmap started to scan, we can see an identification of what the processes are or what the services are that are listing on those ports. We can also see an accurate determination of the fact that it's a Windows 8.1 platform with the build number 9600. We can see a lot of other very useful information too. But essentially though, what we can now see is that this machine, this target machine, is a Windows machine, and there's a good chance that my stolen credentials might allow me in. Now we have a good idea that our stolen credentials might work to help us to break into the Windows victim machine. Let's see what the attacker would do, which steps the attacker would follow. First, the attacker is going to launch the Metasploit console. Metasploit console is an extremely powerful hacking tool that is used by penetration testers, but also by attackers out in the wild, including script kiddies. Here we can see the console launching, and we can also see that as of today there are 1909 different ways that Metasploit has of breaking into computing infrastructure. For those exploits that are successful, a payload can then be chosen to be executed on the target machine. So to save on typing, I'm going to load in the configuration required for the attack, and I'll show you what that enables us to see. So this is the configuration before we run the attack for the attack on the victim machine. We're going to be using the ps-exec Metasploit module, the PowerShell exec Metasploit module. Its configuration is for the machine called MedFinance on port 445 using the admin share, and then these are the stolen credentials. This is the user ID, and then this is the password hash. This is the hash that I'm going to use to gain access to the machine. If the module executes successfully, it will then execute a payload, which in this case is what's known as a reverse shell. In this case, it's a reverse HTTPS shell, meaning that it's going to have the appearance of a user on the Windows victim machine going to this IP address, .11, to a port 443, which is the HTTPS port, looking like a perfectly legitimate thing for the user to be doing, and not a successful attack as is really happening. One other important detail is this auto migrate step. Basically, when we come in to the PowerShell exe process, we want to make sure we don't hang around on that process for long, because Windows Defender or any other anti-malware software may attempt to kill us, in which case what we're going to do is to migrate into the LSAS process, which is a core authentication process in Windows, and it's something that nothing is likely to want to kill. So let's bring this back down to size. Make sure we're looking at log activity in QRadar. I'll zero that off so we can see. Okay, so I'm going to start the attack. So we can see that we got into the machine because we have an interpreter prompt, but we can also see the migration from PowerShell.exe to LSAS. So let's see what QRadar saw while that happened. A lot of different things were spotted by QRadar, but some very important points to note are, of all of the pieces of information we can see, the most fundamental point is that QRadar has determined that the Metasploit ps-exec module has been detected. This is the most actionable piece of information that you can see and requires immediate attention. As the demo goes on, we can see what options we have for containing the risk. So if we scroll right, we can see some information, some interesting information. Here, for example, we can see the process migration from PowerShell.exe to LSAS. In other words, we caught that as part of the attack. We're also seeing the network connection to the attacking platform on port 443. We can also see some registry event settings occurring, amongst many other actionable items. If we go to our Offences tab now, we can now see that the description of the offence has changed to ps-exec has been launched from a compromised host. We drill in to this offence, which, remember, has the same ID as it has before. We can see that the number of events and flows are increasing. But let's have a look and see which rules have fired now. So we've got a number of rules that have fired that have all been contained within the same offence. So we can see that the original connection to a malware host is here. We can see the process migration, and we can see the identification of the Metasploit ps-exec module. If we go into the rule to see why this fired, we can see that it fired because certain registry event settings were set up in a way that is completely characteristic of a Metasploit ps-exec module being executed. And that's why it determined with confidence that that module had been executed. If we now look into the rule action, we can see that as well as increasing the severity of the incoming events, and as well as ensuring that we create a new event or an offence, we can see that we've set its credibility and relevance to 10, and we've indexed it on source IP. So that's great, and it's good to be able to keep track of things within an offence, but when something this serious happens, perhaps we need to take automated action. So within QRadar and Resilient, we have a number of options for containing an attack. A simple and effective one straight from QRadar is to execute a command to a third-party piece of software or security control, such as an internal segmentation firewall, for example, or an EDR solution with a command to sandbox the host or to take the host effectively off the network. We'll also see that Resilient offers a powerful selection of options both for manual and automated containment of this particular event. Now that the attacker has successfully breached the machine, let's see what can be done. On the attacking platform, let's check and see who I am. It's notable that I've got in as system on this platform without having to bypass UAC or user access control. And this is one of the characteristics of a pass the hash attack, that you don't have to go through that stage. So if the user belongs to the administrator group, you go in with system privileges immediately. And this is important because now I can do pretty much anything I like on that platform. For example, if I open up a notepad process on the victim machine and type pkill notepad, I can kill that process. If I open up Internet Explorer, pkill iExplore, I can kill that too. Let's go further into Kali to see what options there are. At this stage, I could run a hash dump. What you should be able to see is that this is the same hash that was used to gain access to the machine. If we're connected to a domain here, I could gather the usernames and encrypted passwords of all of the domain users and use those for subsequent attacks. And the most likely scenario is that I would then sell them on to other people who would like to have access within this organization. Another thing I might do is search for some high-value files, maybe Excel files ending in XLSX. So why would I want to do this? Well, I'd like to steal them, I'd like to own them, and then I'd like to delete them. So I've got some leverage over the victim, where I can then potentially send a ransom note with a Bitcoin address to. So I can see that I found some high-value files. I'm going to go to the directories in question. And I can see that I've got 3 spreadsheet files containing sensitive information about the company, customer lists, and salaries. So to obtain those files within Kali is a very straightforward method of using download. Now I have the files. Simple matter of deleting these by typing del from a DOS prompt means that those files have gone. So I'm now in a position to be able to effectively ransom this user. Another very powerful tool which the NCSC identified is Mimikatz. Mimikatz enables you to be able to see in plain text the password of the currently logged in user. So I'm going to load Mimikatz with the command load kiwi. Here we can see the Mimikatz tool, and to be able to see the credentials of this user is simply a matter of typing creds wdigest. Now I can see the plain text password of that victim user. So I've used an encrypted password to break into the machine, and now I can see the plain text password of that user, which I could then use to carry on moving laterally around the organization, but no longer having to make an effort to hack. Now let's open the User Behaviour Analytics app. We can see that there are many monitored users, but the 2 relevant users from the point of view of this attack, victim and also system user, have had their risk profiles increased dramatically. If we select the victim user, for example, we can see that we have information about them, their name, their IP address, And this we've gathered from a connection to Active Directory. And what we can see is the risk profile of this user over time. So for example, from the current attack, we can see that this user has a risk profile of 115, 10 use cases or rules have fired within QRadar, and so on. If we hover over the risk breakdown for this user, we can see resource risk, and within here we can see very relevant information that we've gathered through the attack for that user as the attack has been perpetrated. If we go to user risk, we can see that UBA itself has had rules that have fired, detecting things like exploit tools detected. With this user, it's natural that we would want to add them to our watch list, as well as take immediate action to remediate. So now we should be able to see from the main dashboard in the UBA that this user has been added to the watch list dodgy consultants. UBA monitors users that it sees on the network, as well as users that have been imported from Active Directory. Included within the UBA is a facility to consolidate this user information so that you don't have duplicate users to manage. UBA also has ability through machine learning to learn about users' normal behavior, so that when the user's behavior deviates from normal patterns, additional rules will fire. These take roughly 7 days to learn a model of normal behavior before they will start to fire. And while I've been speaking, you can see that the risk profiles have escalated further. The attacker is going to use the position on the platform to establish a DNS tunnel from the client to the attacker. So to do this, the attacker uploads the DNS client software. So now the DNS client software is on this machine. Back on the attacker, in this other terminal window, I'm going to start up the DNS tunneling server software. So to do this, we start the DNS cat2 server with an argument of a domain name. So I'm going to use my own name with the domain felixmarks.com. So basically, Kali with the DNS tunneling software will now listen to any DNS request for felixmarks.com. In reality, this server would be located on the other side of the planet in a different jurisdiction, and any traffic that is destined for the authoritative name of server name of felixmarks.com would be routed by the DNS network to a server listening for those requests. And instead of answering the requests with name resolution, it will actually set up a tunnel. Okay, so to set the tunnel up now, all I need to do is execute a command of the uploaded DNS client software, DNSCat2, with the argument felixmarks.com. I can now see, because of the fact this text has changed in this window, that the DNS tunnel has been established. If I now go to the control channel, I can create a shell. So I've created the shell, and now I can see the shell, and now I can interact with the shell. So we can see here that I'm in directory private files, which is where I was from my previous Meterpreter session into this machine. I'm going to change directory into Windows to System 32, because there are a lot of files in there, and I want to do a directory listing which will cause the DNS Analyzer app to fire. So before I do anything more, let's look at DNS Analyzer. So far nothing detected. If I now go to the Network Activity Viewer, specifically look at the DNS tunneling view, I'm very soon going to see what DNS tunneling actually looks like. So let's cause it to fire. Let's do a big directory listing. So all of this directory listing is happening through the DNS tunnel. As you can now see, the DNS tunneling traffic has been created in anger. I'm going to press pause. So what we can see here is how DNS tunneling really works. We can see that we have a domain name of felixmarks.com and then what appears to be a subdomain or a host name with what seems to be random selection of letters and numbers. This is actually the encrypted tunnel traffic, which you can see as the query and response. So any IP protocol can be encapsulated as this tunnel traffic handled by this server, which is the DNS tunneling server. If you're not looking for this traffic, you won't know that it's going on. And because of the way the DNS network automatically passes off queries to authoritative DNS servers, it's very hard to detect. So let's set that running again. Now we can see that an offense has been fired by the identification of DNS tunneling, because these red dots here indicate that these network flows have been identified as part of an offense. If we go to the DNS Analyzer app, we can see that DNS Analyzer has observed and processed a large number of domains and that it's generated 3 events. Let's go and see what these 3 events are by looking in the offenses. So the offense with the ID 568 now has its name changed once again, but this time to the latest offense to have caused it to fire, which is DNS tunneling detected. We drill down into the offense, we can see that now quite a large number of events, 91 in this case, and quite a few flows, 1653 and counting, have all been associated as part of this offense. This is how, with QRadar, we're able to process large numbers of events, large numbers of network flows, down to a small number of actionable offenses. Now let's see what Watson would have made of this attack. This is a Watson investigation that we can see for the victim machine ending .25. On the left-hand side under key observables, we can see 1 high-value asset that's been associated with an attack, 4 malware families that are known to have happened within the context of the attack. We can see the IP address of the known malware host that was the phishing host at the beginning of the attack. We can see the hash, the MD5 file hash of the malware itself as identified by QNI as it traversed the network. We can see the URL of the malware host, and indeed we can see the domain names associated with it. And we can even see information about the malware itself, including the malware family. On the right-hand side of the screen, we can see how Watson app has automatically mapped the tactics and the techniques observed during the attack onto the MITRE framework. So for example, for execution, we've seen that PowerShell is the technique for the tactic of execution. Privilege escalation as a tactic, the techniques of process injection and the creation of a new service were involved, and others, including, for example, for credential access, a credential dumping tool, which we also saw. For command and control, we can also see that Watson has correctly identified standard application layer technique, and that specifically is DNS tunneling. So lastly, for Watson, we can see the value that Watson has added graphically. If I uncheck the Watson Enrich tab here, we're looking at the indicators of compromise as we could have seen them before Watson. If I drill down into this a little, we can see here the malware host ending .219. We can see the malware hash. We can even see the executable name, but these have not been joined together. Watson's used its corpus of knowledge, its connection to X-Force and to other threat intel services, to automatically understand the connection between these IOCs. So if I now click Watson Enriched, the value that Watson has added is in being able to connect all of these indicators of compromise together. So we have the malware host, the URL, the malware hash itself, and indeed the malware and the malware family.
So I have the full details about my offence in the offender screen, and now I've decided I do really want to investigate what's going on with this security incident. So what I'm going to do is send it to Resilient. So Resilient is my security orchestration, automation, response platform. So it's going to help us manage the case. It's going to help us move the offence through the right groups of people within my organization. It's also going to help enrich automatically the data points that QRadar has given me. So QRadar has obviously got a lot of events, flows, information, IP addresses, URLs, hashes, and a lot of these will apply to other parts of my infrastructure. So I can use things like a threat intelligence enrichment. I might look at endpoint. So what I'm going to do is send to Resilient. Now we can do this fully automatically, i.e. every offense that gets created to QRadar goes straight into Resilient. And this is how most of my clients have it set up. But nonetheless, we're going to do it manually this time. So I can click OK, and this is now being created over in Resilient. Now, if we wait a few seconds in the background, it's creating the incident, and then it's uploading all of the data from QRadar. So what we can see is it's launched us straight into QRadar. We have our playbook for our system intrusion. So these are the steps to go through to remediate. And we also have some other information, things like the QRadar ID over here, so we know what it's linked back to. And if we go back to our offense and refresh, we'll see that actually underneath the offense, there's now a note saying it's been transferred to Resilient. There you go, the API escalation has happened. We can also go ahead and sync the notes between the QRadar case and the Resilient incident. But again, in most cases, most of the communication now, the case management and the organization of effort and work on this incident is going to be done from Resilient. So back in the playbook, I want to start following the process of what I need to do to respond to this incident. So I can mark myself as an owner of the case, give myself some due dates, some SLAs of when I need to complete these tasks by. But let's say I go ahead and complete all my work on schedule. I'm pretty happy. We know this is a pretty severe incident because of the information that's come from QRadar. We can also see it's high severity and resilient, and that's because of the information from Watson and QRadar as well. And so now we're into really the phase where we're looking at forensics and deeper threat intelligence on both the links that were provided, the user's endpoint, etc. And I'm not a smart guy, so I'm not really into being able to take care of that kind of stuff. So what I'm going to do is just escalate this to the L3 team, and they're going to take on working on this incident. So you'll see as soon as I click the button, the owner on the right-hand side changes to L3. So Felix is in that group, and Felix is going to be notified that he needs to start responding to this incident. He can get notified by email or in the platform, or he can get a text message as well. But it means we can start to collaborate on this. Felix could also remove me from the investigation now if he didn't want me to be able to see the work that they're doing, making sure that if this was really a serious breach or involved, particularly sensitive corporate data, he can make sure that I can't see what's going on as someone who might not be cleared or have the appropriate business level to be able to access this.